What if AI could help predict a dangerous storm faster, design better medicine, and test new engineering ideas before they are built? Most people think AI is chatbots, images, and chips, but Anima Anandkumar works on a different question. Can AI learn the physical world? Not just words, not just pictures, weather, fluids, molecules, turbulence, systems that move, break, and change in real life. She is an Indian origin AI scientist at Caltech whose work on neural operators helped push AI toward scientific modeling. So, the real question is what made her career extraordinary and what proof did she build? By the end, you will see why her story is not just about artificial intelligence, it is about making AI useful for the real world. Anima Anandkumar studied electrical engineering at IIT Madras and earned her PhD from Cornell University. Her career moved through some of the strongest technical environments in the world: MIT, UC Irvine, Amazon Web Services, NVIDIA, and Caltech. But the important part is not the list of institutions, the important part is the pattern. At every stage, her work asked a bigger question: how can machine learning become useful for complex real world systems? Here is the simple version. A lot of AI is good at recognizing patterns, but the real world is not just patterns. Weather moves, fluids flow, materials bend, waves travel, molecules interact, airplanes face turbulence. Traditional scientific simulations can model these things, but they are often slow and expensive. AI can be fast, but if it does not understand the structure of the problem, it can be unreliable. So the challenge is this: can AI become fast enough for modern science but still serious enough for physics? That is where Anima Anandkumar's work on neural operators becomes important. A neural operator is not just another AI model with a fancy name. Think of it this way: instead of only teaching AI to recognize a photo or finish a sentence, this kind of work helps AI learn how physical systems behave. Scientific systems often change across scale, resolution, and conditions. Neural operators are designed to learn relationships between complex functions, which makes them useful for problems like fluid dynamics, weather, waves, and materials. The consumer version is simple. Her work helps move AI from pattern recognition towards scientific modeling. That is a much bigger ambition. Now, pause here because this is the part that makes the story bigger than one scientist. If AI can model weather faster, that affects disaster planning. If AI can model fluids faster, that affects engineering. If AI can help with molecules, that affects medicine. If AI can simulate complex systems faster, that affects how quickly humans can test ideas. This is not AI as entertainment, this is AI as infrastructure for science. So, what proof did she build? First, research depth. Her public Caltech profile connects her work to AI, neural operators, tensor algorithms, and AI for science. Second, institutional credibility. She became a Bren professor at Caltech. Third, industry impact. Public profiles connect her career to Amazon Web Services and NVIDIA. Fourth, scientific applications. Her lab highlights applications across climate, flight, engineering, medicine, and foundational AI methods. And fifth, public recognition. In 2026, Caltech announced that she was appointed to the United Nations Secretary General's Scientific Advisory Board. Here is the part that matters if you are building your own technical career. Many people wait for their work to become visible, but Anima Anandkumar's story shows something different. Invisible technical work becomes powerful when it solves a hard problem, survives serious evaluation, and creates evidence other people can point to. The question is not, am I famous enough? The question is, what problem did I solve and what changed because my work existed? Anima Anandkumar's story is not just about AI, it is about the ambition to make science faster, deeper, and more useful. That is what made her career extraordinary, and that is the proof she built. Subscribe for more stories of women in tech whose work shaped the future before most people noticed.